Hey, 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 I'm back for part 2. Let's learn some more about water, shall we? So, starting at the top, water is the greatest solvent on the face of the earth. Not everything will dissolve in water, but a whole bunch of things will. That's why we call it the universal solvent. It dissolves most things. Not all things, but most things. So there's some things you need to know, like solvent. That's the thing that's doing the dissolving. Your example for that would be water. If you look at solute, though, that's the thing being dissolved. Remember, we kind of talked about this last unit. Solute, whenever we talked about water potential, it's coming back. Solute is solid particles. This would be something like salt that's in our picture. Could be sugar, could be an acid, could be a base. Solution. Ooh, we've talked about solution too. So put out beside there just as a note, an example. Solution equals solute plus, instead of using just the word water, we're going to say solvent because that's the most correct term. Solvent. So that's plus solvent. Remember, your solvent is water, but let's be scientifically correct and use solute. Ooh, and I've also put out there your example. Kool-Aid is a great example of a solution. Think about what makes up Kool-Aid. It's Kool-Aid powder and a little bit of sugar, depending on your preference, and a whole bunch of water. Think about what you're out beside the Kool-Aid. What's your solute in that? What's your solid particles? Ooh. Kool-Aid powder and sugar. And then what's your solvent? What dissolves that Kool-Aid powder and that sugar? Water. Super easy. So if we look at this picture, it says, see the water forming shells. See, it is circling that sodium and that chlorine that made up salt. And in this picture, which one's going to be your solvent? That's right, water. And what's going to be your solute? What's it breaking up and dissolving? Awesome. So, alright, so hydrophobic. This is probably one of my favorite things to talk about. Hydrophobic and hydrophilic molecules. Remember, I wrote out there, hydro means water, phobic means fearing of. Please underline that. Please underline where it says fearing of. It fears something. Look at the picture of how this interacts. Your examples for these are going to be lipids. Now, lipids is a fancy term for fats, oils, waxes. These are also going to be things like grease, things like that. So fats, oils, wax. And know that these cannot attach. Water can attach to hydrophobic molecules. Put yourself a star out here. These are water haters. Think about it. Haters stick together. They do. They hate on the same thing. They all hate water. So if we look at the oil that's been dropped in this water, here's the water. Here's the oil. Is that oil mixing with that water? No. Because these are water haters up here, they're going to form a barrier between itself and water. They don't want to touch water. They don't want to be near water. They don't want to have anything to do with water. Because they sit there and go, ew, water's gross. I hate water. I hate water too. Let's just bond and we're not going to touch water. That's what they do. They don't interact or mix at all. But on the other end of the spectrum, there's hydrophilic. Please underline that philic means to love something. So if you have a boyfriend or a girlfriend, you could say that you are, I don't know, little Johnny philic. I just love little Johnny. He's so cool. So you're Johnny philic. Now, because it's It loves water. Draw you a little t-shirt out beside here. This will help you. It may seem silly, but it'll help you. They wear their I love water t-shirt every day. If it's clean. And if it's not, they wash it in water, which is exciting to them. They meet every Tuesday night, have a meeting, and go, I just love water. Me too. I made punch. Guess what the solvent is? Water. So no, because they love water so much, they can attach to it. Because think about it, if you love something, you want to be around it all the time. You want to attach yourself to it. And then, remember, it loves water's polarity. Like salt. Salt loves water. It doesn't mind being dissolved by water at all. So hydrophobic, hydrophilic. Haters and lovers. Now, let's look at some wet chemistry terminology. We need to talk about something called dissociation. And what dissociation means is it refers to water breaking apart hydrogen protons in hydroxyl ions. Now, just to clear up, hydroxide this is an ion, so think about what we talked about with isotopes and ions. Ions are elements, or in this case, it's a compound. Compounds can be ions as well. All ion means is it has a different number of electrons. This guy over here, this is hydronium, but because it's positive, it means it has a lot of hydrogen protons. This guy over here named hydroxide, the reason that he's negative is because he's kind of lacking a hydrogen electron, and that's okay. This is going to come into play in just a second whenever we talk about acids and bases. And I do ask that you go ahead and write this scale down, because if you don't, I won't give you time in class, because you could do it right now. So let's look at this pH scale. Now, pH and pOH, they are just scales telling us if something is acidic or if it's basic. Now, what does that mean? Let's first look at the pH scale. This is the pH scale right here. This is pH. Please highlight that all pH means is that if we want to know if something's an acid, it is a substance that gives away hydrogen protons. Remember, they're giving something away. So remember, if you give something away, you're positive, because you're giving away your negative electrons, so you become positive. Now, this scale goes from 0 to 14. We're going to draw this scale out here. So, 0, 1, 2, 3. Ooh, that's a bad 3. Let's redo that 3. It looks like a blob. We don't want a 3 to be blob. 3, 4, 5, 6, 7. We're going to start there. 0 to 6. This is going to be an acid. Why we name it an acid is because, remember, we're giving away hydrogen protons. Please highlight that 7 is neutral. That means it's kind of like Switzerland. It doesn't take sides. It doesn't say, hey, I'm acidic, or hey, I'm basic. He just says, look, I'm in the middle. I don't side with either one of you. I'm Switzerland. I will be neutral. And if you go below 7, you may be an acid. If you go above me, I'm 7. 8 through 14, you get to be basic. But I'm staying in the middle, guys. I'm not taking sides. So, please highlight what I just said. pH scale, if you're less than 7, you're an acid. If you're greater than 7, you're a base. So, we just drew that part of the pH scale. We just drew the acid side. So, let's draw so starting where you left off with 7, we're just going to continue the line down. Remember, 7's neutral. He's Switzerland. If you go from 8, 9, 10, 11, 12, 13, 14, You are a base. And if you're a base, that means that you give away hydroxides, that OH that's negative. Now that's the pH scale. That's the pH scale. Somewhere else, like on the other side of the paper, we're going to draw the pOH scale. So, remember, pH, that H stands for hydrogen. This is the pH scale. Now, let's look at the pOH scale. Remember that OH stands for hydroxide. Well, it's 0 to 14 too. So let's draw. It is the, put you a note out beside here where it says pOH scale. Put opposite of pH scale. They are opposite of each other. So whatever something is on the pH scale, it's the opposite on the pOH scale. So if we have 0, 1, 2, 3, 4, 5, 6, 7. Ooh, 7's still neutral though. He is. He's Switzerland still. He never changes. But on the pOH, make sure you label this as the pOH scale. If you're 0 through 6, you're not an acid. You are a base. It's just opposite. On the pH scale, 0 through 6, you're an acid. But on pOH, you're a base. It's funky, I know. But then if you are, we're going to continue this. Remember, he's neutral. 8, 9, 10, 11, 12, 13, 14. These guys, now think about it. On the pH scale, 8 through 14 was a base. On the pOH scale, you are an acid. You're the opposite. So please make sure you highlight that. Moving on to buffers. You need to know you're going to deal with acids and bases in chemistry. You're also going to deal with buffers as well. A buffer is a substance that can resist changes in pH or pOH. They can't really change. They resist change. You ever think about somebody who just stays the same all the time? They resist change. They're stubborn. Buffers, if you want to put out beside here, that buffers are stubborn. They're stubborn as a mule. They don't like change. Also know that it can take on or give off either those hydrogen protons or those hydroxides to maintain an even pH or pOH concentration. Now, the example we always give you is an example of a buffer is bicarbonate. Bicarbonate is, it has this little, its molecular formula is COH3 negative. That means that it has 1 hydrogen, 1 carbon, and 3 oxygen. But it has an extra electron, so that's why it's negative. Now, why do we need bicarbonate? We want bicarbonate because you want to keep your blood at a pH of 7.4. If your blood's too acidic, you could have problems. If your blood's too basic, you could also have problems. So know that your bicarbonate's going to regulate it as needed because of the food, the drink, or the air that we put our bodies into. So remember, also highlight, this is just for you to think about. That bicarbonate, it will actually take those hydrogen protons from the blood to become that carbonic acid and raise your blood pH. And then it can travel to the lungs where it is converted to water and CO2. Now, out beside that where it says breathing out, as you breathe that out, you get rid of it. That's one way it regulates things. It takes those hydrogen protons, because it gains some more protons, it turns into a new substance, that carbonic acid, It'll raise your blood pH, and then it will travel to the lungs. It'll kind of get rid of those protons. It'll match up with that oxygen that goes to your lungs, turn it into water, and you breathe it out. Now, that bicarbonate can also give off those positive protons and lower your blood pH. That's not important for your test, but a lot of people ask me, well, what's so great about it? It helps you regulate your blood pH. You don't want to have problems with your blood pH. That could cause all types of medical problems. And then our last thing we're going to go by and talk about is acid precipitation. So, just all this means is any form of precipitation. That means water falling from the sky, whether it's rain, snow, sleet, ice, fog. It has a low pH. So out beside where it says low pH, think about it. If it's got a low pH, is it an acid or a base? Ooh, put out beside there. Good job. It's an acid. That's why we call it acid rain. So acid rain is water falling in either solid, liquid, or gas. And it usually has a pH of less than 5.6, which is incredibly acidic. It's acidic enough that it can rot, or not rot, but it can disintegrate marble statues. We'll watch a short video on it tomorrow. It can destroy buildings. It'll kill plants. It'll corrode your house, your car. And why this happens, they're like, but why does this happen? It's because of sulfur oxide and nitrogen oxide. They end up in the air together, and they combine with the water in the air. But where does it come from? It comes from fossil fuels burning. This is like, you can put yourself an example out there, factories. This happens because of factories. Factories. They burn those fossil fuels like oil, gasoline, charcoal, and then we have problems. That sulfur oxide and that nitrogen oxide gets in the air, gets trapped in those water molecules, goes up in the clouds. It condenses in the water cycle. That cloud gets so heavy that it starts precipitating, raining down. That water's full of acid, so it's going to start corroding things. And it can become very harmful to the environment, as well as wildlife, people, their stuff. You will mainly find this in very industrious areas. You find this a lot where you have a lot of factories and high populations because people work in those factories and they live close together. So that is part 1 and part 2 of water properties. I hope this was helpful for you, and I will see you tomorrow.